Okay, so now I'm recording the session. Okay. Now, also remember that I introduced you the number E, which is also called Euler's number, also known as Napier constant, the number E. This is an irrational number that is between 2 and 3. So Euler's number E is an irrational number and its value is something between 3 and 2. An important exponential function is y equal to e to the power x. So y equal to e to the power x is something close to 2 to the power x in terms of the graph and also its behavior. So this is y equal to e to the power x. And you see when x goes to minus infinity, the limit of this guy is 0. And when x goes to plus infinity, it's plus infinity. And its value at 0 is 1, because any number to the power 0 is 1. Okay. So we will see more about this function in the future, but remember this. So the next topic is logarithm. It is basically the inverse of the exponential function. So logarithm is the inverse of exponential function. So simply means when you say that, for example, let's talk about exponential with base 2. We have to be careful about the base and we have to keep track of the base. So when I say 2 to the power 3 or 2 cubed is 8, that's equivalent to saying that logarithm of 8 with the base 2 is 3. Okay.
Mm-hmm.
Or you say 2 to the power 4 is 16. That's equivalent to saying that logarithm of 16 with the base 2 is equal to 4. So you can basically say it in this way. So what power or what exponents of 2 is equal to 16? That is 4. What exponent of 2 is equal to 8? That is 3. That's basically log of 8. Okay. Now what is log of, if you do this logic, what is log of 32? And again, you have to keep track of the base because the base is important. If I change the base, so that gives us another logarithm. So what is log of 32?
I think 5.
What is log of 256? And so on, so forth. Okay. Okay, so in general, So if I talk about base 2, I say that if y equal to 2 to the power x, that's equivalent to saying that log of y with base 2 is equal to x. Okay.
Mhm.
But you can also have this for any number, not necessarily 2. So you can also repeat this with like y equal to 3 to the power x. So the inverse of exponential 3 to the power x is log with base 3. Okay. So there is another way to say this. You can also, you can also switch log with exponential. That means, so if I tell you that the log of some number a equal to b, that's equivalent to saying that a equal to 3 to the power b. Okay.
Mhm.
Now let me give you some examples of solving equations. So example. So you remember we have some exponential equations. Now we have some logarithmic equations. Solve for x. So log of 5x minus 1 with base 3 is equal to 2. So that means 5x minus 1 is what? Log of what number with base 3 is equal to 2? Let me draw a table just to clarify. So this is like x, and this column is log with base 3. So if x is 1, what is log of 1?
0.
0, because 3 to the power 0 is 1. If x is 3, what is log of 3 with base 3?
1.
1. Because 3 to the power 1 is 3. How about 9?
2.
Log of 9 is 2, because 3 to the power 2 or 3 squared is 9. And then 27 is 3, and so on and so forth. Do you get the logic?
Mhm.
So can you solve this equation now?
Yes. I think x is 2.
Because 5x minus 1 has to be 3 squared, that means 5x minus 1 is equal to 9. That means 5x equal to 10. So
Oh.
x equal to 2. So something to keep in mind, which is helpful. So let me write this formula for you. If I say that log of b with base a is equal to c, and a, remember that a has to be positive, then that means that's equivalent to b is equal to a to the power c. Okay?
Mhm.
Repeat this with yourself every day. Day and night. Okay?
Mhm.
Write it bigger.
Oh, but A can't be 1, I think.
Yeah, that's right. A can be. Because when exponential form, when the base is 1, then anything is 1. So when 1 to any power is 1, so it's not an interesting function.
Mm.
Yeah. So okay, so log b with base a equal to c means b is equal to a to the power c. Okay.
Mhm.
Now it's time to look at the graph of. So graph of log. So first of all, remember we have to fix the base. So let's look at f of x y equal to f of x equal to log x with the base 2. Okay. So this is the inverse of 2 to the power x, okay? So when you have the inverse of a function, so the range and the domain will switch. So the domain of the inverse function, so that means the domain of the logarithm is the range of the exponential, okay?
Mhm.
And the range of the logarithm would be the domain of the exponential, okay?
Mm.
So domain of f is equal to range of y equal to 2 to the power x. Now, what is the range of 2 to the power x? You remember? I mean, these are all the same, basically. What is the range of 2 to the power x?
From 0 to opposite infinite.
Infinity. So it's the interval from 0 to infinity and not included. Okay. So the range of 2 to the power x is equal to the interval 0 to infinity. So that is the domain of log. And the range of log is basically let me write this. The range of y equal to log x is equal to domain of y equal to 2 to the power x. And what is the domain of 2 to the power x?
The real number.
It's everything. It's the real numbers, the set of real numbers, or you can say from minus infinity to positive. Okay. Now let's try to draw the graph. Okay, so first I draw the graph of the original function, 2 to the power x. I mean, original, both of them are original, but I mean, we began with 2 to the power x. And that's the graph of 2 to the power x. Now the graph of log with base 2, whenever you want to draw the graph of an inverse of some function, you basically have to flip it around the line y equal to x. So this is the line y equal to x. If you flip this graph around this line, you get the graph of log. So this purple one is y equal to log x with base 2. And the blue one is y equal to x. Okay, so for example, you see the point 0, 1 is on the graph of 2 to the x, right? This is the point 0, 1. And here is the point 1, 0 in the graph of log. So something to pay attention to. First, the domain of log is what? The domain of log. So let me write f of x is log x with base 2. So we saw that the domain is the interval 0 to infinity. And it's clear from this picture also. You see the domain. Negative numbers are not in the domain. So that's the domain of f. And then it's also important to notice that log of 1 is 0. If x is less than 1, then log is negative. If x is less than 1, then log x is negative. And if x is greater than 1, then log x, sorry, this is positive. Okay. Okay, now there are some rules for log, for logarithm. And I have to tell you something. If you don't see anything written for the base, it's either 10 because, and this is something which is not, some people take it as 10 when you see, for example, y equal to log x, and there is nothing in the base. So some people take this as 10. So when the base is 10, you don't put it, right? And some people, I mean, take it as e, the Euler number, okay? And it depends on the, I mean, what literature you look at or you read. But anyway, so in this course, so our convention is when nothing is written, it's 10. That means log with base 10. And if for base equal to e, I use this notation. y equal to log, I use this notation, ln of x. ln is the natural logarithm. So the natural logarithm, so when nothing is written, that means log with x with base 10. So the natural logarithm means the logarithm with base e. So this is the inverse of, so when we say y equal to ln of x, that means x equal to e to the power y. So the natural logarithm is the inverse of exponential with base e. So it's the same, it's somehow close to base 2, for example. But this is very important for many reasons. This is the most important function in the world, e to the power x and the natural logarithm, which are inverse of each other's, okay? Okay, so let me also draw the graph of these two guys, which are very similar to 2 to the power x, but just. So first, this is e to the power x. And for the natural logarithm, it's the inverse of e to the power x. It looks like something like this. So the blue one is the natural logarithm. The green one is e to the power x. These are inverse of each other's, okay? Okay. Now I wanted to tell you some rules about the logarithm. So when you add two logarithm, like the first rule, log of a plus log b is equal to log a times b. And here base doesn't matter. So this is true for any base, 2, 3, 10, e, any base. Log of a plus log b is equal to log a times b. So sum of two logs is equal to the log of the product. That's basically the rule. The second rule is that when you subtract, you have to divide. So in particular, minus log of something, like the minus log of x equal to log of 1 over x. Okay. And another important rule is when you multiply a log by some number like r, this is equal to log of x to the power r. I mean, you can, I mean, these are equality. That means log of x to the r is equal to r times log. Okay. So remember these rules, and let me give you some homework, another homework. Again, these are some equations that you have to solve. So one, So let me say this is question 3 because I gave you 2 questions. This is question 3. So what is, do you have this question? Log 5x plus 1 plus log of 5x minus 1 equal to 0. Again, I say that if I don't put anything, that means log with the base 10. But here I just put 2. Actually, for this question, doesn't matter, actually. But because that's, you will see why it doesn't matter if you solve this. I can give you some other questions. And question 4, draw the graph of okay, guys. So you have 4 questions at least for today to do. And let me know if you have any questions, please let me know.
I guess C in question 3 means log x plus 1 based on 3, but not log x based on 3 plus 1, right?
So let me be more clear. That means this.
Okay.
Yeah. So let me, So let me just write this more precise. Okay. So just look at question 3, part B. Part B is easy because when you say log x with the base 25 equal to 1/2, that just means x equal to 25 to the power 1/2. Right? What is 25 to the power 1/2?
5.
How about, what if I said log x with the base 25 is minus 1/2? If the right-hand side is minus 1/2, then what would be x?
1
Log
over
x
5.
with the base 25 is minus 1/2. Then x is 25 to the power minus 1/2, which is 1 over 25 to the power half, which is 1 over 5. Okay, guys?
Mhm.
So I want you to work on these questions, and you can ask me if you have any problems, just talk to me, okay?